Hi there, my name is Nathan and I'm incredibly excited to be running you through RenderBoost, a frame interpolation add-on that can save you time rendering animations. So, how does it work? Well, RenderBoost allows you to only have to render a portion of your animation. RenderBoost will then use the power of frame interpolation to fill in the frames that you haven't rendered, thus achieving much faster rendering results. RenderBoost offers a variety of options when performing interpolation, such as the setting that we call the multi-value. This multi-value can range anywhere between 2 and 6, and this will determine how many frames you have to render and how many frames are generated by the RenderBoost system. Here we can see a chart showing off the effect of each multi-value. If we zoom in here to multi-2, we can see that for every rendered frame there is a generated frame. Essentially, you're rendering half of your animation and letting RenderBoost do the rest. Let's now have a look at multi-6. We can see that for every frame you're rendering, 5 additional frames are generated. This means you're rendering a sixth of your animation, cutting the render time down considerably. Moving on, we also have a setting known as scale. This property allows you to control the size of the images used for performing the interpolation calculations, and subsequently generating the interpolated frames. The scale value can range between 0.1 and 2. A value of 1 represents the original size of the input frames. Higher values, such as 2, indicate scaling up the input frames, in this case doubling the resolution, whilst lower values, such as 0.5, indicate scaling down the frames, in this case halving the resolution. By adjusting the scale property, you can control the level of detail and smoothness in the generated interpolated frames. Lower scale values can result in faster interpolation, but may lead to reduced image quality or loss of fine details. On the other hand, higher scale values can provide more precise interpolation at the cost of increased computation time. This allows you to find a balance with the scale setting based on your specific requirements and the available computational resources. Experimenting with different scale values can help you achieve the desired trade-off between interpolation quality and processing time. It's important to note that the scaling only affects the frames during the interpolation process. The final outputted frames will have the same resolution that you set for the render. Now we have had a brief introduction to the add-on, let's see it in action. Here we have the barber demo scene from Blender Foundation. I have set up a simple camera fly-through tracking the chairs. Firstly, let's do a render without RenderBoost, just so we have a reference of how long this render takes using conventional means. Brilliant, it's done. Let's have a look at the result. It's good, but this animation took about 3 hours to render. Let's now see what RenderBoost can do for this project. Firstly, we need to configure RenderBoost. Now, RenderBoost can be used in two main ways, automatic and manual. Manual allows you to perform interpolation on a pre-existing image sequence by simply selecting the multi-value you wish to use, selecting the file directory to the desired image sequence, and pressing the Start Frame Interpolation button. If you wanted to render an image sequence in mind of future interpolation, you can set the step value in the Frame Range tab to match the multi-value you plan on using. For example, if you wish to only render half of your animation, you can set the step value to 2 and render the animation. To make life easier, in the RenderBoost window, you can sync the step value with the multi-value, allowing you to render your project and to perform the interpolation later with the correct settings. For this demonstration, we are going to be using automatic interpolation mode. This syncs the step value with the multi-value and waits for the rendering to finish, and it will then automatically perform the interpolation process on the newly rendered frames. It's at this stage I like to increase the timeline by about 5 frames, creating a buffer to ensure the whole frame sequence is interpolated. Multi-value 6 need about 5 frames, whereas multi-value 2 won't need any. Right, let's start the rendering. Great! Now it's finished rendering, and as we had automatic interpolation mode enabled, the RenderBoost system will immediately begin to interpolate the frames. You'll see in the directory you have chosen to render your image sequence to will now have a newly created folder called Output. This is where RenderBoost places its newly generated frames. Now, let's add the times together to get a total time for how long RenderBoost took with a multi-value of 2. Roughly, that took half the time to render than without RenderBoost. Let's now have a look at the results. Practically identical. Let's see if we can push it further. This time we will jump straight into the deep end and set the multi-value to 6. Wow, that was quick. 30 minutes and the render has finished. Let's see how long it took to generate the interpolated frames. Fantastic! Let's add these to the chart and see where we stand. A whopping 81% faster than the full render. So, let's have a look at the results. Okay, so as you can see there is clearly a loss of smoothness, especially in the reflections. However, Multimode 6 isn't about creating perfect renders. I use it for drafting and iterating on my projects. Saves me tons of time all the way up to the final render, which these days I often use a multi-mode of 2 for the best quality and yet still saving me half the time. If these are the kind of time savings that you're looking for in your latest project to meet tight deadlines or to just iterate through your projects faster and more efficiently, then please check RenderBoost out following the link in the description below.